Hey everyone, and welcome. Today, we're diving into one of the most powerful tools in statistics, something called the Five-Number Summary and its visual partner, the Boxplot. We're going to see how you can take a messy, chaotic list of numbers and turn it into a story that's actually clear and easy to understand.
You know that feeling when you're staring at a giant spreadsheet? Maybe it's test scores, sales figures, whatever. It's just a wall of numbers. It's kind of meaningless at first glance. So how do you find the actual story hidden in there? Well, today, we're going to become data detectives, and we're going to learn how to use a few key clues to solve that mystery. So here's our game plan. First up, we'll get our detectives toolkit all set up. Then we'll learn exactly how to build our key piece of evidence, the boxplot. After that, we'll figure out how to read it, to interpret what that picture is actually telling us. And finally, we'll put it all together and solve a case with a full worked example. Sound good? Let's go. Okay, so every investigation starts with getting your tools ready. And for us, that means the Five-Number Summary. This thing is the absolute foundation for everything else we're going to do.
Just think of this as the basic stats for your data. It doesn't matter if you have 10 data points or 10 million, these 5 specific values give you an incredibly powerful and simple summary of the whole picture.
So what are these 5 key numbers? Well, we've got the minimum, that's your lowest value, and the maximum, your highest. No surprise there. The median is the one smack dab in the middle. Then you have the first and third quartiles, which we call Q1 and Q3. Just think of Q1 as the point where 25% of the data is smaller, and Q3 as the point where 75% of the data is smaller. Together, these 5 numbers slice your data into 4 equal-sized chunks.
And that's really what makes this so powerful. In just 5 numbers, you get the entire range from the absolute lowest to the highest value, you get the center point with the median, and you get the spread of the middle half of your data between Q1 and Q3. It's a complete snapshot, all in just 5 values.
So we have our toolkit, those 5 numbers. Now, what do we do with them? How do we turn them into a picture that tells a story? Let's look at how we assemble these clues into our main visual, the boxplot.
We're going to follow a really clear 5-step process. First, we calculate one more quick value from our summary. Then we're going to set up some boundaries that we call fences. After that, it's pretty simple. We just draw the box, draw the whiskers, and then mark any weird points that stand out. Let's break it down. First up, we calculate something called the interquartile range, or IQR for short. This number is really important. It tells you the range of the middle 50% of your data. Basically, it's the width of the box in our box plot. And the formula couldn't be easier. You just take Q3 and subtract Q1. That's it.
Okay, next we set up our fences. Now, you don't actually draw these on the final plot. Think of them as invisible boundaries that we just calculate. We take our IQR, multiply it by 1.5, that's just a standard rule, and then we subtract that number from Q1 to get our lower fence and add it to Q3 for our upper fence. These fences are what we use to officially spot any outliers.
And this brings us to an absolutely critical point. This is a super common mistake, so listen up. The whiskers on the plot do not just automatically go out to the fences we calculated. Nope. They only go out to the farthest data points that are still inside those fence boundaries. Getting this right is totally key to drawing an accurate box plot.
So what about any data points that do fall outside our fences? Well, those are outliers. They're the exceptions to the rule, right? The values that are way different from the rest of the group. We give them a special mark, usually a little dot or an asterisk, to show that they're not part of the main story.
Okay, we've built a box plot, the clues are all assembled, so now it's time for the big reveal. What is this picture actually telling us? This is where we learn to read the shape and uncover the data's story.
The real beauty of a box plot is that its shape tells you, at a glance, about the distribution of your data. Where's that median line sitting inside the box? Are the whiskers about the same length or is one way longer than the other? These visual cues tell you everything you need to know.
For instance, if the median line is right in the middle of the box and the whiskers look pretty much the same length, then you've got a symmetric distribution. The data is nicely balanced, spread out evenly on both sides of the center.
But what if the median looks like it's been pushed over to the left side of the box and that right whisker is really long? We call this skewed right. It means most of your data is bunched up at the low end, but there's a long tail of a few high values stretching way out to the right.
And you can probably guess the exact opposite can happen too. If the median is on the right side of the box and the left whisker is the long one, that's skewed left.
In this case, most of the data is clustered at the high end, with a tail stretching down toward a few unusually low values. All right, enough theory. Let's put this into practice. We're going to apply everything we've just learned and solve a case using a sample set of test scores.
Okay, first things first, we need our detective's toolkit. For these test scores, here's our 5-number summary. The minimum score was a 45. Q1 is 59.5, the median is 71, Q3 is 82.8, and the maximum score was a 95.
Now with that summary, we calculate our interquartile range. We just take Q3, which is 82.8, and subtract Q1, 59.5, and that gives us an IQR of 23.3. Remember, this number is the key to finding our fences.
So let's use that IQR to calculate those fences. For the lower fence, we take Q1 and subtract 1.5 times our IQR, which gives us 24.6. For the upper fence, we take Q3 and add 1.5 times the IQR, which comes out to 117.6. So any score below 24.6 or above 117.6 would be flagged as an outlier.
All right, time to check our data against those fences. Our lowest score was a 45. Is that inside the fence? Yep, it's way above 24.6. Our highest score was 95. Is that inside? You bet, it's well below 117.6. So this leads us to our final conclusion. Case closed. No outliers were detected.
So what is the final story of these test scores? Well, when we actually draw the box plot, we see the median of 71 is sitting almost perfectly in the center of the box between Q1 and Q3, and the whiskers on either side are about the same length. The story is crystal clear. This is a symmetric distribution. The scores are spread out nice and evenly around the middle.
So there you have it. The 5-number summary and the box plot are just incredibly useful tools for turning a confusing data set from a total mystery into a clear story. You now have the skills of a data detective. The only question left is, what story will your data tell?